starting our presentation. I am sure it came in your mind, what do you mean by there is nothing wireless about wireless? So let me now introduce, let me explain it first. All our antennas, Wi-Fi antenna or cellular network antenna that are provide all of us with the unwired freedom for our devices from cell phones to laptops, they all have wire. So this wire that enables them to provide that communication bandwidth. Also, with the BOE technology that allow the reduction in having to run different cables to devices where possible, as well as the elimination of having different contracting deployment in the site. So also today we are going to cover the planning cabling infrastructures to support the Wi-Fi for today and for tomorrow. So let's discover now our today agenda, as it is divided into 5 parts. I will start first with the wired versus wireless. So we need to choose wired or wireless system, or we need to have a joint wired and wireless to improve our future proofing. Secondly, we are going with the Wi-Fi today and tomorrow, current Wi-Fi 6 and the future Wi-Fi 7. Also, the impact of fifth generation on the Wi-Fi will be in our topic. Then we are going through the wired network impact on the wireless regarding the performance, data rate, and the number of users that can be served if we have the wired and joint of wired and wireless solution in your network. Finally, we are going to the Wi-Fi cabling infrastructure recommendation for today and tomorrow in order to have to maximize your return of the investment. So let's move to the first slide, sorry. Let's move to the first part of the presentation, which is about wired versus wireless. As shown in the right figure, this is the wired solution. Wired solution give you a mean of dedicated bandwidth for each user. So each user, you have no sharing between the user, and each device can reach up to 10 gigabit per second if you are going with Cat6 channel. Also, we have another advantage for the security. Then when you are comparing between wired and wireless, you have now dedicated bandwidth and you have more secure than the wireless solution. On the other hand, the wireless system channels, that mean you are sharing your bandwidth between the available devices. That means if you are increasing the number of devices in the system, the performance will be decreases in your network. So you have now each device have each cables, but here you have the sharing between the available devices using one cable. Also, one thing is very important when we are comparing between the wired and wireless. The comparing must be about the power delivery. Power delivery, as each device will need power. So to compare between the wired and wireless must taking into your consideration the power delivery comparison. This is example, we have a greenfield installation. So we have no power outlet available in your site. So the wired solution means that using the BOE, you can deliver power data to using single cables to the device. Also, using the BOE++ solution, you can deliver up to 71 watt to the end devices. But on the other hand, this is the wireless system. The device is using, gets the power using either power outlet or using the battery. So in wireless solution without BOE system technology, you will be need around 4 power cables and 1 data cables versus the wired solution. Wired solution scenario, you are needing in this example only 3 data cables, but here you need 4 power cables and 1 data cable. Taking into your consideration that low voltage cable are cheaper than to install than the power cable. Even the wireless, if your device is wireless and using the batteries, the power device using battery must be put into consideration the long-term need to continuously replace this battery. So you have high cost and you need more time to replacement this battery. I'm not to say that wireless is not a good idea when you are planning for the system, but we need to think about the entire installation cost. The cost of the post solution, not just the first installation cost, but however, the actual cost of the wireless network may be hidden than the wired solution. So the message here that we need to have a strong cabling solution to encourage the people to offload their devices to the wired network. So if you are encouraging the people and allowing people to offload their devices to the wired solution, you have improving the wireless performance. Okay. Okay, next. Look at this table. This is a summary for the PoE and technology. The new PoE++ standard increased the number of pairs running the PoE from 2 to 4. The old one. The PoE++ increased the number of pairs running the PoE from 2 to 4. And based on our the standard now approved, the recommended cables to running the PoE++ is category Cat 6A. That is the recommended for the PoE++. Due to the increasing of the power delivered to the device. If you look at the PoE++ type 4, now you are delivering around 71 1 watt to the end device, which is 3 times of the PoE+ power. Also, the current increased from 0.6 ampere in each pair. Now it is around 1 ampere in each pair. The main impact of this increase of the current in the pairs, that's the heat. So you need to choose the cable with high operating temperature. That to ensure that the ambient temperatures for the cable plus the cable bundle temperature rise doesn't exceed the cable operating temperature. Also not exceed the standard. The standard says that you must ensure that the temperature rise not to increase more than 15 degrees over the ambient temperature. Also now, this is the PoE. In this table, you have the main PoE application worldwide in 2019. If you look at this table, you have around 23% of the wireless access point, which is around 26 million ports shipped in 2019. And also in the chart, the expected or estimated number of ports that shipped in 2019 is around 117 million. Also, it's expected to increase the power, the PoE port to increase between 11 and 12% annually. Okay, now you can check the questions that shown on the screen and feel free to solve it in 30 seconds. You have 30 seconds to read this question and answer. Feel free to answer it. Okay, the question was, can the brownfield, your brownfield, if you are using Cat 5e or Cat 6 in your existing site, can it support greater than 1 gigabit per second? The answer is yes, around 49%, and around 51 said that it's cannot support more than greater than 1 gigabit per second. The answer yes. If you are using, you can using your brownfield. If you have Cat 5e or Cat 6, you can be support the increasing for the data rate, and you can even transmit 10 gigabit per second for the Cat 6 based on the TIA guidelines that it tell us it can be support from 37 to up to 50 meter. But you must take into consideration the alien crosstalk in your environment. But based on the NBASE-T, if you are going NBASE-T, second. Based on the NBASE-T technology that specified a new data transmission rate 2.5 and 5G. This new transmission rate, which allow for your brownfield, if you are working in brownfield site, you can using your existing Cat5e or even Cat6 cabling to support the high data rate required for your needing for your wireless access point. But must look at this first to this table, the risk assessment that indicate where is the problem. The problem may occur. And as shown in this table, it is not assured in all cases, but the cable quality and bundle size, also even the cable length for the bundle size will be effect for your ability of the existing infrastructure to operate this high data rate. But generally, based on this table, the longer cable run together in bundle, the higher risk can be achieved for the peak performance. And if you are looking at for 5G, it is low risk if you are going with Cat5e, but it's medium low if you're going with this bundle up to 50 meter. Also, it is medium if you are going from 50 to 100 meter. But our recommendation for any new green field that you need to install Cat6e cable instead of Cat5 or Cat5e due to the immunity of it from alien crosstalk, and it is the only cable as is shown in this table, risk assessment table. The Cat6e, it is the only cable that guaranteed to work in all data rate up to 10 gigabit per second. Here, as we shown, 10 gigabit per second, it's medium high. You have risk if you are going with Cat6, you have medium high risk if you are bundled up to 50 meter. But now in the market, you can find multi-gigabit switches that can be support these features in the NBASE-T technology. Okay. Next. Okay. This is the different cabling category comparison, which is indicate the regarding the PoE. The Cat6e as shown, it is the only optimum for the regarding the thermal performance. Cat6e is the optimum and preferred to be installed regarding the PoE, as we said. Also for the 10 gigabit per second to be supported up to 100 meter, the Cat6e will be the recommended to use it in your greenfield site. As said before, that Cat6 can be support 10 gig bus with limitation in bandwidth based in TIA TSP 155-A guidelines. It specifies that Cat6 can be going with 10 gig up to starting from 37 up to 55 meters, depending on your alien crosstalk environment. But the recommendation to working with Cat6A from starting. This is the summary that we for the first topic regarding the bandwidth. Wireless uses the shared bandwidth, and wired is dedicated bandwidth. Compared to the PoE, as we said, no cabling reduction with Wi-Fi when including the power, because we will need the power outlet for each device. Cat6a, it is recommended for the next generation PoE, and Cat6a is recommended for speed up to 1 gigabit per second with no any performance risk. As we said from the risk assessment, for the speed up to greater than 1 gig, the Cat6a is recommended with no risk, performance risk. Okay, let's move now to the Wi-Fi today and Wi-Fi tomorrow, to understanding where the Wi-Fi is today and where it is going. One of the observation that more devices per person than ever before, and by 2025, the average number of network devices per person worldwide is expected to increase between 6 to 10 per person. Also, the wireless standard, another observation, the wireless standard data rate is increased faster than the wired. And in the span of just 10 years, wireless technology have seen Wi-Fi 4, 5, 6, and also now Wi-Fi 7, which is engineers are working at working hard now to finalize the Wi-Fi 7. So this is the standard we have. Also now this is the wireless standard comparison. As shown in the table, the data rate, the first data rate in the green table, the data rate maximum, it means the maximum data rate required for the Wi-Fi port for the maximum number of users. So the data rate required, maximum data rate required for Wi-Fi 5, it's around 7 gigabit per second. For the Wi-Fi 6, it needs a port 9.6 gigabit per second. And it's expected to be greater than 10 gigabit per second when launched the Wi-Fi 7. So starting from Wi-Fi 5, the recommended cables starting from Wi-Fi 5 to using the Cat6a for the required data rate. Also the Wi-Fi 7, it will be need 2 cables, Cat6a cable, to running the data rate required. It will be greater than 10 gigabit per second. Also regarding the PoE requirement enhancement, if you're for Wi-Fi 6, if you are using for high density environment where all optional features will be enabled, that sorry, the PoE required will be PoE++. You will need for the access point PoE++ if you are enabled all the optional feature to have the high density environment for the Wi-Fi 6. Okay. As shown in this Wi-Fi is expected in this chart, also the Wi-Fi 6 is expected to grow larger and faster than any other standard. And as shown in the chart, it's expected to be the largest number units sold worldwide in 2022. So now, what is the difference between Wi-Fi 6 and Wi-Fi 5? And what is the advantage from Wi-Fi 6 over Wi-Fi 5? As you see, the first one, it is the main features for the Wi-Fi 6, it is TWT. TWT, it means target walk time. Target walk time, it means that where it tells the Wi-Fi radio when to sleep and when to wake up to receive the transmission data, which is increase the battery life for the end devices. These features will be reduce the power consumption with no impact for the performance. So using the TWT features in the Wi-Fi 6 will be reduce the power consumption with no impact on the performance for your network. Another features added in the Wi-Fi 6, it is OFDMA. OFDMA, it stands for orthogonal frequency division multiple access, which is used in cellular network. And in the old Wi-Fi standards, they are using OFDM. But now the OFDM, it's in FMA, it's included in the Wi-Fi 6, which is reduced the latency less than 1 millisecond for the data packet transmission. Also the OFDMA with the improved beamforming, another feature in the Wi-Fi 6. OFDMA with the improved beamforming, it's increased, and the improved modulations, QAM modulations, it increased the data rate 4 times. The data rate increased 4 times, and also the capacity as well increases. So in the next slide, I will discuss with you and explain the difference, the main difference between the OFDM and OFDMA. And also we are discussing the beamforming added to the Wi-Fi 6 and the special stream, number of special stream included in Wi-Fi 6. One of the main biggest improvement in Wi-Fi 6, as we said, it's additional for OFDMA. OFDMA instead of OFDM in the old Wi-Fi standard. Simple way to think to get know the difference between both of them technique. Assume that we have a semi-truck and it is loaded with pallet. In Wi-Fi 5, in the left, Wi-Fi 5 pallet, we're only backed with only single product. We have the pallet in this semi-truck, and every pallet is filled with a single product. And so not all the pallet filled with the capacity. But in Wi-Fi 6, the product can be combined on the pallet. Pallet here, it means the subcarrier's frequency available for the network, or channel bandwidth. You can see that it is a channel bandwidth available. It is a pallet, and the product filled inside it, it means the users. So in OFDM, it means you are serving only one user on a time. You have every you have a time slots, and every time slot you are serving only one user. But in Wi-Fi 6 OFDMA, you can serve more than users in a time. So OFDMA, it is a more communication efficient than OFDM, with a communication efficiency around 96%. And in Wi-Fi 5, the communication efficiency was 52%. The conclusion is, when you are knowing the difference between the OFDM and OFDMA, that OFDMA, it is more efficient, as you have a sharing between the user for our time slot. We are not serve one user only in a time slot. You are serving many users, sharing in the bandwidth. So we have more efficient and improve the throughput as well, while also reducing the latency as shown in this figure. Okay. Also, another special streaming. Special streaming started and available in Wi-Fi 4, 5, and 6 now as well. But special streaming, it means it is a type of the transmission technique used in the MIMO system. MIMO, it means multiple input, multiple output wireless technology, that you are transmitting independent and separately code data signal called streams. You are transmitting streams at the same time. Special stream increased the data rate and by the number of streams that are transmitted. This is example for what I am saying. This is a MIMO 4x4, it means four antennas for transmitting. And this is the data rate to be transmitted. It is split into parallel. So we have transmitted 4 special for this example. MIMO 4, you are transmitting 4 special stream. So we have multiple stream can be discriminated at the receiver via our signal code words and transmitted simultaneously at the same time with our signals code, different signals code. So receiver can be discriminated it from its or signals code. Also, number of theoretical special streaming in Wi-Fi was 8, but the practical number of special stream in Wi-Fi 5 was 4. But in Wi-Fi 6 now, the special stream is around 8 special stream per transmission, per user. Also the beamforming. Beamforming, it means in this example, as you can see in the left, this is no beaming, no beamforming. The antennas is transmitting the radiation in omnidirectional radiation. But here in this example, it is antenna, MIMO system antenna with directive antenna, our beamforming antenna. Beamforming antenna, it means you are shaping the radiation pattern. This is radiation pattern or the power, the shape of the power transmitted from the antenna. You have a multiple antenna and you are shaping the radiation pattern of the wireless access point to focus the energy toward a specific device. You are focusing the radiation to a specific device. So for longer reach, you can have a more directive antenna, so you can have a smaller coverage and with directive antenna and can reach high distance. And each beam here can be coded up to multiple special stream. In Wi-Fi 5, each beam can be have a 4 special stream per beam, and practically now you have 8 special stream per beam for Wi-Fi 6. So now you have higher number of special stream per beam that allow you have a high density Wi-Fi 6. This is the main advantage for Wi-Fi 6. You have beamforming, improved beamforming, which increased your high density. You can be put the antennas closer to each other without any interference or risk for the contention between the neighboring. So you now have a high density Wi-Fi 6 compared to the Wi-Fi 5. And now we are reducing the risk of contentions from the neighboring using the beamforming technology. So now what is the expectation from the Wi-Fi 7? The expectation from Wi-Fi 7, it will be EHB. EHB, it means extremely high throughput. And now the 0.11be task force are developing the Wi-Fi 7 now. And the FCC is planned now to have a new spectrum. It's planned to have a new unlicensed spectrum between 5.925 up to 7.125 to open it for the Wi-Fi spectrum that have around 1,200 megahertz will be available for the Wi-Fi 7, and Wi-Fi 6 is compatible also. If launched this spectrum, it will be compatible with Wi-Fi 6. Some technology also will be available in Wi-Fi 7, like coordinated OFDMA, coordinated null steering, and distributed MIMO to enhancement the beamform. And point 11 BE task force stated objective now from the Wi-Fi 7 that you need 2 Cat6a cable per access point to support the required data rate and to use the common cable type. So now this is the summary for the difference for the Wi-Fi of today and tomorrow. As we said, Wi-Fi 6 is expected to be the largest and fastest growing Wi-Fi standard regarding other Wi-Fi standard. Wi-Fi 6 offer you 4 advantage over the Wi-Fi 5. Speed increased 4 times, the capacity as well, battery life using the TWT target wait time, also reduced the latency to be less than 1 millisecond. Wi-Fi 6 also can offer improved access point density, as by using the spatial streaming and improved beamforming, you can be increasing the density for the Wi-Fi 6. Also, Wi-Fi 7 will be even better and will be required 2 Cat6a cable per access point. So now, next slide. One second. Okay. So now the impact of 5th generation of the cellular network on the Wi-Fi 6. The question here is, will 5th generation have an impact on Wi-Fi 6? Please check now the question will be shown, and feel free to answer it in 30 seconds to know will 5G have an impact on the Wi-Fi 6 or not? Okay, the answer for the will 5G have an impact on Wi-Fi 6 or not? 70 say that yes, 30 say no. But the answer it's no. The answer for this question it is no. 5G will not expected to have any impact on the Wi-Fi 6 because the 5th generation expected to be the similar for the old cellular generation. And the Wi-Fi will be continue to be the network choice within the enterprise indoor network. I'm talking now to compare between the Wi-Fi 6 and 5th generation regarding the indoor network. So it will not impact on the Wi-Fi 6. Both will be together, will be complementary. So now let's discuss in the following slides what is the difference between the 5th generation and Wi-Fi 6 and why it will not impact on them. Okay. Sorry. Okay. 5th generation versus Wi-Fi 6. Regarding the available bandwidth, as shown in the figure, the Wi-Fi 6 worked in unlicensed spectrum, and it has about 90 megahertz within 2.4 gig, and have 500 megahertz bandwidth for 5 gig, as Wi-Fi 6 working in 2.4 gig and 5 gig. You have a dual frequency can be enabled. Also, as we said, FCC planned to have a new bandwidth, unlicensed bandwidth for the 5G. So we have around 1,200 megahertz will be available for the bandwidth. So the Wi-Fi 6, it will have a total bandwidth around 1,790 megahertz. On the other hand, the 5G operate in licensed mobile spectrum, where each carrier will be allocated its spectrum, which is around approximately bandwidth 200 megahertz. So now we have 1,790 megahertz for the Wi-Fi 6 and 200 megahertz in 5G. So Wi-Fi 6 and 5G will be coexist, and the message is Wi-Fi 6 and 5G generation will be complementary and hand over to each other because the largest bandwidth available for the Wi-Fi 6. Also the capacity. The real key differentiator between the 5G and Wi-Fi 6 when you are comparing between the 5th generation and Wi-Fi 6, the real key differentiator is the capacity. The capacity for the Wi-Fi system in general can be measured in data rate density. This is the data rate density. It is the metric when we are comparing between the 5th generation and Wi-Fi 6. We have the data rate density, megabit per second per 1 meter square. So in Wi-Fi 6, it is estimated to have 400 megabit per second per 1 meter square. But in 5th generation, the estimated data rate density, it is around 10 megabit per second per 1 meter square. So one of the reasons for the biggest difference between the Wi-Fi 6 and 5th generation, it is Wi-Fi 6, it has a much larger bandwidth available. Also, it has the ability to target device using the beamforming. As we said, we have the beamforming and we can be target the specific devices, and we have also the large bandwidth. Now, check the question will be shown on the screen, and you have also 30 seconds to solve it to compare between 5th generation and Wi-Fi 6. The question is, the indoor 5th generation network expected to have, we are talking about now the network required for the in-building wireless. When you are distributing the 5th generation inside the building, huge building, we need to compare between 5th generation and Wi-Fi 6 regarding the network or passive network will be distributed. Now, the answer is right. 64 says that the network required for the 5th generation will be need small cells and will need structured cabling like IT network, and antenna can be connected using the fiber, and the copper as well can be connected. The antenna, the DAS antenna, distribution antenna system can be connected to the copper and enable the PoE. This is another advantage also for the Wi-Fi 6 regarding the inputs, the indoor network. So when you are talking about the next slide, 1 second. Okay. When you are distributing the 5th G inside the building, we have the DAS system. DAS system, it means you have distribution antenna system, which is the distribution for the cellular network inside the building. To distribute this, the cellular network inside the building, we have 3 types of system. We have the passive DAS, hybrid DAS, and active DAS. Active DAS, you need to have structured cabling system like fiber and the copper, and not coaxial cabling. For the old DAS system, they are using coaxial cable and repeater for the passive, and the hybrid was using the fiber for the vertical and the horizontal using the coaxial cable. But regarding this, for the input network, the 5th generation indoor network DAS system expected to have active DAS. Active DAS, it means you have a cabling of choice will be structured cabling system, fiber and the copper like IT. So, but the disadvantage is that the component for the indoor building wireless will be as shown. In the first, you will have the cabling, you need to have an indoor small cell, also a 5G radio unit, core network connection, and also you need to duplicate for each carrier that is supported inside the building. But the main advantage for the Wi-Fi 6 is that Wi-Fi, the network is universal. Network is universal means that you can work with all devices. Also, it is much less expensive than the 5th generation to be distributed it and to implement for the coverage. So based on this factor, indoor network required and bandwidth and the capacity as well for the Wi-Fi 6, it's expected that the percentage of the traffic offloaded by the mobile devices to the Wi-Fi from the cellular network will be actually increases in the future. Also expected both will be coexist as and handover between them. Okay, this is the summary of the impact of 5th generation on the Wi-Fi. Wi-Fi, as we said, has a more bandwidth available than the 5th generation. Wi-Fi 6 has a more capacity than the 5th generation and less expensive to deploy it. As we said, Wi-Fi, it's universal, just cabling for the copper fiber, but 5th generation need more component to be distributed for the active DAS. Also, the expected amount of traffic offloaded to the Wi-Fi to increase, and it is expected by 2022 to increase up to 71%. So now let's move to the wired network impact on the wireless. This is the best of both worlds. That message we need to have, as we said in the beginning, that we need to have a wired network and the wireless network together in the system. So let's discuss now the impact of to have a wired and wireless system in the network. Let's think first for any device, for any office. If you have any office, people may have a mobile phone on the wireless network, and mobile laptop may be on the wireless network, and when the desk is charging, so it will be connected to the wired. Also, there are employees that can use the desktop in wired. So many environments now conducive to having devices on both wired and wireless. So does this convey specific advantage that to have a joint between wired and wireless? The answer is yes. And in bandwidth, we have conducted experiment, and we have a white paper for this analysis that to prove that when a wireless network is deployed along with wired network, it delivers an improved and future-proofed wireless experience for everyone in the network. So our scenario for the analysis as shown, we assumed that in the analysis, we assume that we have 36 users. Each user assumed to have 2 devices, mobile and the computer. So we have around 72 total available devices, and we did 2 configurations during our analysis. One access point, as shown in this figure, one access point configuration, and the 72 devices distributed into 3 rings. And we did another configuration with 3 access point configuration. 72 devices are distributed and spread out into 2 distance from the multiple access point. Our criteria and the performance metric during our analysis, we have the performance metric to quantify the network performance. We have 2 criteria. The first criteria is the performance ratio. What is the performance ratio? It is stand for actual bandwidth available divided by the required bandwidth required by the client. So this performance ratio needed to be greater than 1. As when the performance ratio greater than 1, it means that the available bandwidth in your network greater than the required bandwidth from the client. And the critical and the threshold value for the performance ratio, it will be equal 1. If you are going with performance ratio 1, it means that the available bandwidth will be equal to the required bandwidth from the devices. So we have, this is the first metric, and the performance metric to quantify the network, the performance ratio. Another criteria when you are comparing and to have the quantify the network, it is the probability that simultaneous request simultaneously request occur from client. This is also another criteria, probability that simultaneous request occur from the client. During our analysis, we developed the shown table to understand the network data rate demand. As shown, we have three types of user in the network: high end and middle and low end. And during our analysis, we did it with high and middle user that were used during the analysis. So now the analysis result for the three wireless access point configuration. This is the result from our analysis. We're making the analysis for the 3 access point configuration with around 72 clients. We have 72 clients distributed around 3 access points, and we have also wired network inside our analysis. The x-axis in this test case result, x-axis, it means the total number of client served on the 3 wireless access points. So look at this x-axis. X-axis means total number of client on the wireless access point. So the vertical axis, it means the performance ratio. Performance ratio, that, as we said, the performance ratio must be greater than 1. And this is the minimum or threshold value or critical value for the performance ratio. And this one also is for the probability of 2 simultaneous client requests for the service. So as shown in this chart, the result is when we have 72 clients on the wireless, if you are look in the left, this 72 client available on the wireless means that we have 0 on the wired. The performance ratio for the network, it is around 1.2. And if you are look, this is the red curve, it means the performance ratio. When we have 72 clients on the wireless and 0% on the wired, the performance ratio was 1.2. And the probability that 2 simultaneously request for the service from the client, it is around 6%. When we are moving to having 48 clients on the wireless, look at the 48 on the wireless and 24 of the devices is offloaded to the wired network. When 24 offloaded to the wired network, and we have now 33 devices on the wired network, the performance ratio increased to 2, equal now 2. And this means that you have improvement in the performance ratio around 60%. Also, if you are looking to the probability of 2 simultaneously client, the performance rate, the probability for 2 simultaneously client is decreases from 6% to 2%. So you have improved your network when you are encourage the devices to be loaded and offloaded from the wireless to the wired. Also look at the blue figure. If you are looking to this blue figure, the network performance, this is the network performance for the 3 access point configuration. As we said, we have 3 access point configuration. And in the x-axis, it means this is the total client in the wired and wireless network. This is number. It means in this chart that it means total number of client in the wired and wireless. And we have a different curve inside the chart for the different percent of the offloaded from the wireless to the wired. So, for example, as we said, the performance ratio must be greater than 1. And for example, if you are looking at the blue one in the first, it means that you have 0% of user inside the wired system, and all the user in our analysis conducted to the wireless network. If you are get the interaction between the performance ratio and this curve, you will be find that when the network with all client on the wireless network, you can be support up to 76 client on the network with the wireless and 0 device on the wire. But if you are looked at the 33% on the wire, the curve number 4, the line number 4, the orange one. Orange one, it means that if you have a 33% of the client moved and offloaded to the wired solution, it means that the maximum number of clients that can be served in this network, wired and wireless, it increased to 110. The conclusion from this curve, it means that when we are offloading around 33 of the network on the wired network, you can be support now up to 110 clients versus we can be support 76 clients when we have 0% on the wired network, which is increased 45% and more. So the message is joint of wired and wireless network in your enterprise solutions, you have offered improved future proofing. So now this is the summary for and conclusion for the wired and wireless solutions impact. Many environments can be supported both and wireless networks. This is the message to have a wired and wireless solution together and strong wired system to be encourage the people to offload their devices to the network. Also, the offloading to the wired network can improve the wireless network by greater than 25%. The wired network is better future proofing for the wireless network. So it will help you to increasing the wireless network by the wired network. So now our Wi-Fi cabling infrastructure recommendation for planning when you are planning for day 1, 2, and 3. So now check the question shown on the screen and feel free to answer it in 30 seconds. Okay. The answer is, from your opinion, and what is the preferred number of cables that can be recommended when you are during your design? How many cable you are planned to install per access point? 71 says that it's 2 cable Cat6a, 21 says that 1 only cable, and 8% for the 4 cables Cat6a. Okay. The answer is the recommendation from our side to have the 4 cable Cat6a. So let's discuss about this in the following slides. Okay. Okay. When you are designing the cable plant for Wi-Fi 6 or beyond, it is critical to ensure that the cable plant can accommodate for the present and the future data rate and PoE. The message is it must be accommodate for your present and the future data rate and PoE. Our observation and what is the key information shared today is Wi-Fi 6 of today will have data rate need up to almost 10 gigabit per second. As we said, it is 9.6 gigabit per second for the maximum data rate. So you need to have the Cat6a as a standard to handle the PoE and run the data rate up to 10 gigabit per second. The second observation is that the Wi-Fi 6 and beyond have the ability to allow increase the density of the access points. As we said, using the beamforming, you can be increasing the density for the Wi-Fi. So the recommendation, the access point can be spaced closer to each other to increase this density. So we need, the recommendation will be to add another cable if you need to have any increasing for the density. Also, the future Wi-Fi technology like Wi-Fi 7, are projected to exceed the 10 gigabit per second, which is mean Wi-Fi 7 will be required at least 2 Cat6a cable to handle the necessary data rate. So our recommendation from our side to run at least 4 cables Cat6a to reach the access point to support the increased density and to the speeds required in the future. So let's discuss it in details. If you are using now Wi-Fi 6 or Wi-Fi, even Wi-Fi 5, and this in this example, in your floor, you have 2 access points, and you are running now, by our recommendation, you are running 4 cable installed per access point. 1 cable now are used and 3 cable for future. So now in day 1, you have 25 cables used. In day 2, when you are increase the density, it means that you are now using Wi-Fi 6 and you need to increase the density using the beam forming and special stream. So you can, to unused the cable from the left access point, you can, using the 2 unused cable, moved to the new access point, which is spaced closer than to each other. You can be moved it. And now you are using 2 cable from the 4 cable you are installed per access point. And now you are using 1 cable per access point and used 2 cable from the 4 cables you are installed. Now you have 50% of cable used. And in day 3, when you are upgrading to the access point Wi-Fi 7, 2 cable will be required per access point. So as shown in this figure, 2 cable will be used for the access point. So you have now 100% of the cable will be used. As shown in this table given, this is the estimated cost for the different installation option. You have 3 options. You can be running 4 cable for today. When you are running 4 cables from today, you are cost for X, it's indication for 1 cable installation now, and you have no upgrading for day 1 or day 2 or day 3. Second option, you will be installed 2 cable now to support the increasing of the high density, but will be installed 2 cable, another 2 cable for the 2 access point in the future. So now the cost will be 2x, but the upgrading cost will be expensive, because when you are installing the cable, the wall are up and the building are occupied. So you need site survey and so on. So the cost will be around 20x. For the option 3, you are installing 1 cable now, 1 cable day 2 to support the increasing of density, and 2 cables to support the Wi-Fi 7. The total cost for the upgrading and the initial cost will be around 31. So you have, as shown, it is more expensive to adding cables when the walls is up and the building is occupied. So pay now or pay later. This is a message. You can be answer it to pay me now or pay me later. Okay, this is the summary for the Wi-Fi cabling recommendation from our side. To review it, we recommend to run 4 cable to each access point and use 1 of them now in day 1, and in day 2 to increase the density to using 2 of the 4 cables after increasing your density. And in day 3, you can be use the 4 of installed the 4 cables initially deployed in day 1. So running the 4 cable from day 1, it has the lowest cost and simplest upgrading and the lowest cost. So now let me now briefly state the main point of our webinar, as this is a review. The wired connections offered a high bandwidth and the power over a single cable. New Wi-Fi standard offers significant improvement in the speed 4 times and latency less than 1 millisecond, and the battery life using the TWT features included in the Wi-Fi 6. Also, Wi-Fi 6 and 5G, it will be coexist and Wi-Fi will be increased. Also, the joint between the wired and wireless network will be optimized the future proof for the wireless network. And finally, the recommendation from our side to install 4 Cat6a Cat6a cables per access point to support the current and the future expanding for need for data rate and high density required for the access point. So now, last but not least, I'd like to thank you all for taking time out to listen to my presentation. And I'd be very interested to hear your question on my presentation. Thank you.
Thank you, Mohamed. I hope everyone enjoyed the content that Mohamed shared with us today and shared his knowledge about the planning a cabling infrastructure to support the Wi-Fi for today and tomorrow. I have an overwhelming number of questions here that the audience has submitted. I'm going to try my best to ask Mohamed to answer as many as possible, starting from the first one, which is where does Li-Fi fit into the grand scheme of things corresponding to your topic, Mohamed?
Sorry, again?
Where does Li-Fi?
Li-Fi? No, I didn't talk about it now because it is now it's under upgrading and under not standard till now. So I didn't prepared for it. Yeah.
Another question that we wanted to ask is, do you foresee a possible hybrid PON net delivery to provide a bandwidth capable backbone in place of a large scale Cat6a deployment? And also, would you zone cabling for Wi-Fi more efficient than centralized structured cabling design?
Yes, yes, sure. When you are using the consolidation point and zones, it will be very effective to using it to have a smaller distance for the copper cable to be running, to have the huge data rate requirement. Also for the first part, that to have the PON solutions to using it for it, yeah, it will be very effective and will be help to have to the huge data rate and requirement for the Wi-Fi. So it will be help you when you are using the PON solution for the vertical system.
I see. A lot of people ask the same question, so I wanted to ask you, or consolidate it on behalf of all of the attendees. Is I noticed beamforming in Wi-Fi, can it be harmful to human beings around these antennas? And 5G, does it have any health issues or such challenges that you have come across?
I think Wi-Fi 6 it's still working in 2.4 gigabit per second and 5 gigabit per second now. Wi-Fi 6 working in two range now, 2.4 and 5 gig, and it is working for I think for 10 years. For the 10 years or 15 years, we are working in two region, and still for the 6 gig, it's not approved. But in Wi-Fi 6, we are not using. For example, for the 5G, we planned for using 30 gigabit per second gigahertz for the 5G. So I think it is safe for when you are using Wi-Fi 6.
What do you think about the handsets? Do you think handsets will need to have support for 5G as well as Wi-Fi 6 to make best use of 5G outdoor and Wi-Fi 6 indoor? And what do you think?
Yes. As we said, the 5G, it will be for the outdoor. And I'm talking today when you are comparing the 5G and the Wi-Fi 6 inside the building, in building system. So when you are comparing it, we expect that more people will be going to the Wi-Fi 6 instead of 5G. But when you are going to outside, it will be helpful for using 5G.
I see. What about digital DAS? Do you think we can use digital DAS to combine Wi-Fi and DAS 5G in a single device, providing both services?
I don't think about it, but because in that system, it will be using your current fiber and copper like IT, but it's still RF signals. RF signal, not like the Wi-Fi signal. It is use the RF signal. It will be converted first from the analog to digital, and then the antenna, the DAS antenna will be converted it again. So it will not be combined the both.
I see. And what are the chances that vendors will really require more than the Cat6 uplink per wireless access point using, or versus using multi-mode and separate power?
Sorry, again, sorry.
What are the chances that vendors will really require more than one Cat6 uplink per wireless access point versus using multi-mode or a separate power source?
As we said, when you are comparing between the wired and wireless, it means the device will need power. So you are having the power outlet must be beside the device. So you cannot have the PoE inside the fiber. Fiber it's light, not PoE. So you need to have the power outlet beside the device, or even you have the battery inside it, which is in the long term you need to change it. So it is a separate. But in the wired solution, you have the PoE, so you have a dedicated bandwidth, and you can be delivered data and power to the to the device, not like the wired solution.
And the last question, I mean, to be honest, I have a lot more, but I need to wrap up at some point in time. So the last question I wanted to ask you is, how do you think Wi-Fi 6 solves the problem of efficiency? Do you think Wi-Fi 6 is good for full duplex communication?
As we said, Wi-Fi 6 is more efficient, but it's not full duplex communication. Wi-Fi 6, it is still Wi-Fi. It is the concept for it. It is a single duplex or simplex duplex, but it is have a more efficient because you are serving more than one user. You are not transmitting and receiving. You can be serving, transmitting, and can be served more than one user. As we said, we are using OFDMA instead of OFDM used in the old Wi-Fi. In old Wi-Fi, they are using OFDM. OFDM, you are serving one user in a time, but using OFDMA, it is multiple access. So you can be served multiple user and you have sharing bandwidth, but it is still single duplex, simplex duplex. So this is the difference between it. Also, another thing that is OFDMA, it's like cellular network, so you have the efficiency and the capacity increasing.
I see. Great. Thank you. I really appreciate it, Mohamed. I learned a lot. I hope others did too. I'm going to try my best to wrap up this presentation by reminding you all about the promotions that exist. Use the code EMEA Web 01 to unlock the 10% discount on your standards and publications, or the waiver of the membership fee. And use this time to brush up your knowledge with the courses and increase your certification vault. And to wrap up, as we had mentioned before about the conference, please keep it in mind. These are our new dates. We look forward to seeing all of you there. And while we are conforming towards the end, and I wish I could have asked all the questions that came up, unfortunately didn't have enough time, but for all those questions that could not get answered, please feel free to reach Mohamed or Trident at info@Trident, itrident.com, and I'm sure they will get back to you for any questions that you have for myself or for Bixi, or anything that we can help you with regards to future learning or keep up to date with our future events. Please email us at emea@bixi.org. And while I've been talking, the survey has already popped up on your screen, so please feel free to give us your feedback, answer the questions that exist. And while you're answering these questions, another reminder that the webinar provides one CEC, and the CEC will automatically be reflecting on your Bixi profile. And with that in mind, thank you all for taking time joining us today. Thank you, Mohamed, and thank you, Trident, for enabling us to host a beautiful webinar. And I look forward to seeing you all on my next event very soon. Thank you and have a good day.